So from our amazing experiment, what did we learn? We learned that there's some things that can speed up an equation. So the main thing that speeds up an equation is temperature. As you increase the temperature, your rate will go really fast. So if you want something to go really fast, you heat it up. If you want something to slow down, you can cool it down. If you increase the concentration, in our experiment, we decreased the concentration, and that reaction did kind of go fast, but I think I might have used hot water when I diluted it. So I think that might have skewed that result. Because usually when you increase the concentration of something, you have more stuff in there to react, and so it should go faster. So if you increase the concentration, it should go faster. Which means if you decrease the concentration, it should go slower. Ours didn't work out that well. So next, if you increase the surface area, it should also make your reaction go faster. Our Tums kind of sat on top of all the foam, so it didn't get mixed in very well. So as you let it sit and it dropped down into the liquid, I think the foam kept it from mixing very well. But usually if you increase the surface area, your reaction will also go faster. So increasing the temperature, increasing the concentration, and increasing the surface area makes your reaction go faster. That might be helpful in your conclusion for your lab that you're going to write up and send to me. Okay, so why? Why? Because we want the molecules to be moving closer together and have a chance to react together. So for any equation, some amount of A plus some amount of B turns into some amount of C plus some amount of D for any equation. So I'm mixing two things together and I'm getting two other things. So for any equation, there's a rate for that equation. So how fast it goes. So the rate, R, is equal to the K, which is a rate constant we'll have to figure out, times the concentration of A, and you use these square brackets, that means concentration, to some exponent, times the concentration of B to a different exponent. Might be the same exponent. We don't know if it's the same or different, so I'm going to write this one to the X and this one to the Y. And next time we'll talk about how we figure out all these things. But let's just look at example 14.1 on page 465. It says write the rate equation for the following chemical reaction. And our chemical reaction is N squared plus 3H squared turns into 2NH3. So we get the concentration just by taking the two reactants. So we're going to change this to N. We're going to change this to H squared. Actually, it should be N squared and H squared. And we need to have some numbers to figure out what everything else is. So if all they give you is what the reaction is and they don't give you any trials or tell you how fast it is, this is all you can say. You can say the concentration of this times the concentration of this. That's the only thing you can change. Okay, so how do we figure out the other things? Well, we have to know a little bit more information. So let's pause that here.